Okay, so now we're going to be working with example 2 here. So you're going to do some more practice with this 4/8 that we've been working on with the quadratics here and doing projectile motion. So suppose an automatic pitching machine releases a baseball at a 20-degree angle and at a height of 5 feet. The baseball has a velocity of 100 feet per second. We're supposed to write an equation to express the height of the ball as a function of time. So going back to the equation that we've been using h of t is equal to negative 16 t squared plus the initial velocity, so v sub 0, times the sine of the angle times t plus the initial height. So now let's just substitute all our values in there. So negative 16 t squared is staying right there. The initial velocity there, they said the initial velocity there is 100 feet per second. So 100. And then the sine of the angle, and it says it's a 20-degree angle, so it's sine of 20 times t, and then plus the initial height, and it says it has a height of 5 feet, so plus 5. So h of t is equal to negative 16 t squared plus 100 sine 20 times t plus 5. It says if the batter misses the ball, at what time will the ball hit the ground? So let's go ahead now and let's work through that one. So think through it. What does it mean, at what time will the ball hit the ground? So we're looking for time. We don't have time. And we're trying, it says when will the ball hit the ground? So when it hits the ground, the height of the ball there is 0. So we're going to substitute into our equation over there. It says h of t equals that. H of t is basically your height. So we can substitute 0 in for our height and keep everything else the same. Negative 16 t squared plus 100 sine 20 times t plus 5. And you can also just go ahead and kind of round that 100 sine 20. You can plug that into your calculator there. So I'm going to do that. 100 sine 20. Pull up my calculator here. 100 sine 20. And I get 34.2. So 34.2, I'm going to come down here. We'll say B here is h of t is equal to negative 16t squared plus 34.2 times t plus 5. So now we're plugging in 0 for our height because we said we're looking at part B there. When it hit the ground, it hits the ground. It has a height of 0. And we're going to go ahead and solve now for t. So there's lots of tools you've learned to be able to solve for t here. One tool you could do is you could use the quadratic formula. So I'm going to use that one right now. So use quadratic formula. So remember, this goes 0 equals at squared plus bt plus c. And the quadratic formula says that t there is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So now let's just go ahead and substitute our values in there. So according to our formula up here, our a up here is 16, and our b here is 34.2, and our c there is 5. So I'm going to plug those in there. So the opposite of 34.2 is negative 34.2, plus or minus the square root of 34.2 squared minus 4 times negative 16 times c all over 2 times negative 16. So now that I have it all written out there, we can simply plug that into our calculator. So let's do that. We're going to plug in those values there. And I tell people to go ahead and do the b squared minus 4ac on your calculator there first. So we can take 34.2 squared and minus 4 times negative 16 times your C value, and we end up getting 1,489.64. So coming back over here, let's plug that in here. So T is equal to negative 34.2 plus or minus the square root of 1,489.64. And while I'm at it, I'm down here, 2 times negative 16 there is negative 32. So I'm going to go ahead now and take the square root of 1,489.64. So square root. If I want to get my previous answer, I can just go second answer. It's right above the minus key there. I should say the negative symbol down there, down at the bottom there, bottom right hand corner. So that gives me 38.6. So I get negative 34.2 plus or minus 38.6 nearest 10th divided by negative 32. So now we can go ahead and we've got two answers there. So what I'm going to do is I'm going to take negative 34.2 plus 38.6 divided by negative 32. And if you want, you might want to put parentheses around that if you're going to do it at the same time. And then we've got another solution here. We've got a negative 34.2 minus 38.6 divided by negative 32. So let's find those two solutions there. So I'm going to do that. I'm going to take negative 34.2 plus 38.4. Whoa, let me do that again. So negative 34.2 plus 38.6 in parentheses divided by negative 32. You need to put the parentheses in there because otherwise it's not going to give you the correct answer there, because your calculator needs to know you got to do addition first and then division second. So we just went ahead and we added this together and we get about to the nearest, well, we'll put it down. So 0.1375 is what we end up getting. So now let's come over here and let's do the other one as well. Let's minus those. So doing the same thing, negative 34.2 and I'm going to subtract off 38.6 divided by negative 32. And I'm getting 2.275. Now we're talking about time. Can the ball there hit the ground after negative 0.1375 seconds? No. So, because you can't have a negative time, so I'm going to cross that one out. And basically this is going to be our solution there, 2.275 seconds. So that's our part B there. Now we're on to part C. Part C is asking us now, it says, find the maximum height of the ball and the time at which this was attained. When they're asking for the maximum height, see, this is kind of what our graph sort of looks like. Remember, we talked about maximum, and our maximum always occurs up there at the vertex. So we want to find out what the y value of your vertex there is. So let's go ahead. So the max here is going to occur at your vertex. And we're really looking for the y value of the vertex here. But we need to find a both. So t is equal to the opposite of b, all over 2a. And if you go back up there to your formula up there that we had that negative 16t squared plus 34.2t plus 5 there. Our b value is 34.2. So I'm going to say negative 34.2, all divided by 2 times my a value. And again, I can go up there to part B there. My A value there is negative 16. So I'm going to clean up my denominator down there. 2 times negative 16 there is negative 32. And then I can simply divide that out. Negative 34.2 divided by negative 32 there gives us about 1.1 seconds. So that's the t value. That's when it occurs. So up here you're going to have 1.1 something. So now we got to plug in because we really remember our maximum really occurs at the y value of the vertex there. So let's find it. So our height there is negative 16 times 1.1 squared, and I'm getting this formula from up here from part B, that negative 16t squared plus 34.2t plus 5. I'm putting my 1.1 up there for my t values. So then the next part of there is 34.2, and then the t value there is now 1.1 because I'm substituting in there because it says t equals 1.1, and then plus 5. And then you can directly plug all those into your calculator, and when you get your result there to the nearest tenth, you get 23.3, and we're labeling this feet because that's what the problem says it is in feet and seconds. So feet and seconds. So let's come down here and let's look at our next part. Part D there says we want the domain and our range, and in order to get those, I like to graph it out. So, and we're told also to graph it out here. Part F, so I might do part F and then come back down here. So let's graph out part F and then let's go answer the question about domain and range. So if I graph out F here, we've got the, when it hits the, we've got some values here given to us. First of all, we want to go ahead and get our t values and our h values here. So if we start here at time 0, because that's where we're going to start, that's the at the initial there is 0, and we're going to keep going all the way up to where it hits the ground. And it hits the ground that we found out to be in part B there is when the bottom is what time will it hit the ground? It hits the ground there at, what do you say? I'm going to say about 2.3 seconds. So about 2.3 seconds. So maybe we want to put some other values in here. So maybe like 0.5, and we've got a nice one in here. We got our vertex in here as well. We've got a 1.1, and then we're up there at 23.3 feet. So we know we got those. And then we've got this 2.3. So maybe we'll graph those 4 points there to give us some idea of what's going to go on with our graph. So coming over here, I'm going to kind of graph this out. I'm going to say 0.5, and then at 1, and I'm going by nice even increments, 2, and I'm going to go up to 2.5. And then I'm looking over here, and I'm seeing I have to go all the way up there to 23.3 feet, so I got to figure out what kind of increments I want to go up by my y-axis. So maybe I'll go by 5s, 10, 15, 20, 25. So this is my t values, my time in seconds, and this here on the vertical axis there is my height. So we need these values here. So at time 0 there, which is going to actually give us our y-intercept, which answers our question for letter E there, we can plug in, again, looking at part B there, we had that h of t equals negative 16t squared, and then we had plus 34.2t plus 5. Let's go ahead and let's substitute 0 in for t and solve for h. So at time t there, if I plug that all into my calculator, I get 5. So there's one of my nice ordered pairs. So I've got 2 ordered pairs now, and I got to find the other ones. So I'm going to stop the video, and we're going to go on to another second one here. So the letter